Hey everyone, and welcome back to the final MtoA 510 tutorial series where I'll be finishing up the render and doing some compositing work to make it a little bit more poppy. So before we jump into Nuke, what I did before submitting the last render, I was actually rendering two separate passes in Arnold render view. So one was a volumetric rendering pass, which just looks like this. So all I did was assigning a flat shader to the objects, and then I had my spotlight in the center, this guy, and I was just running this using Arnold render view, and then I was just exporting the EXR file. And then I was also rendering out a deep pass, which I will be using to create the depth of field effect. And to set that up, I went to the render settings, went to AOVs, and let's just delete this for now. I was just creating a custom AOV and I call it deep. And the important thing is you need to change the driver to a deep EXR driver. And you can just render a float value because you don't need the RGB components. Float a single channel deep is more than enough. And I just left the default values as they are. And I just rendered, instead of using Arnold render view, I just used a batch render script, or the batch render command, which outputs each AOV in a separate folder. And after that was done, I got the deep output and I brought them into Nuke using the deep read. And if you want to see them, they look like this. A deep EXR is a depth representation of your rendered image. So if I zoom to the correct camera location, you can actually see that it aligns up and we see those mushrooms appearing. And the cool thing about it is you get the depth perception and the space in the depth. So this was a quick introduction to that, and now we jump into Nuke and I will show you how to create the final results of the image. The final results, which we will be creating in today's Nuke compositing session, will look like this. So as you can see, I brought in the volumetric light. It's really subtle in here, and I added a bit more particles. You can see all these things are actually particles I have been creating afterwards. And then we have the nice bokeh, which comes from Peregrine PG bokeh. It's a pretty powerful and awesome depth of field generator, and it's very accurate. And it also takes in deep inputs, and it takes camera inputs as well from Maya directly. So to get things going, my render from Maya looks like this. So the one we finished off in part 4. There we go. So this is what it looks like without any treatment. And I'm not so happy about a few things, which are especially in the foreground, with like this thing. It looks really bad and it's in focus, unfortunately. So I need to do some tweaking on it. The rest of mushrooms, I think I like them. The surface on this could be better, but it's still overall it's pretty cool. And as you noticed, I rendered it in the end without depth of field because the depth of field render, it looked unfortunately too noisy in the nice close-up renders. You can see, and you don't get the nice bokeh effects. That's still something Arnold needs to work on. So what I did now, I was rendering without the motion blur, and the benefit of doing so, you don't need as many AA samples to resolve the image. And you can see this is pretty clean now, and we don't have blur, but I rendered the deep pass, so we can use the deep to generate the depth information, and you can use that for the depth of field plugin. What you also can do if you don't want to render the deep, you can render out the Z pass, which is just enabling in Maya, switching quickly back to Maya, you just enable the Z pass, or you add it if you don't have it yet built in, and then the Z should be here, and then you can just add it, and then you get also a depth representation, but it's just planar in 2D. It's not a 3D presentation. So the first thing I was doing was I wanted to create like particles, just some little dust or something which is floating around. And to do that, I was using a particle generator, and I've got the final render here, but I will reset it up, and we might go back and forth if I forget things. Because I'm not really a comper, I'm just like a lighting artist with some comping knowledge. So we create a particle emitter, which will just create particles like this. So it's just a stream of particles. And what I did, I was changing the input parameter to a box. So I was creating a cube, which is a 3D cube, and this is my emitter. And then the particles get emitted from that surface. And then I also, what I did, I was changing the display mode to be just a wireframe, and I was changing the rows and columns to 1, so I don't really see the whole cube, and it's not that distracting. And then you can see the particles get emitted like only from the points. Let's just increase the emission rate maybe to 50, and then you can see what's going on. And then you can change the emit from, and I want it from the bounding box, which says it's emitting from the center. And currently it has a direction, and we want it to go random. So it's a random direction, and then it's being populated. And as you can see, they get spread out. So what you can do for that, I think, if you have no velocity or no spread, let's see. The cool thing is we don't really need it. We can just keep it static because we just render a still frame, and I won't be showing you how to do like floating particles in the air. So let's just see if I can get it right. If not, we can just ignore it because it's not important. They should just be if I think it should be the speed actually. Just a sec. Mute, just muting my machine. There we go. All right, so if I don't have velocity, everything is in the sphere environment, box environment, which is exactly what I want, right? So now I can just go about to scale the box, and then we get scaled particles as well. And for fast interaction, obviously you don't want to emit like 50 particles, just go to 1, and then you can scale the cube, and this is how I did it. So now you get the nice fast feedback. So that's the one thing. And then I need the render camera. So what I did here, I just exported the camera from Maya as an alembic, and this is the camera, so I just have it here. And then I created a scanline render, and the scanline camera goes to the camera, and the object goes to the particle emitter. And then we should have a camera, and you can see the particles are here, and you can also see the cube is there, right? So then I'm just now placing the cube better into the scene. There we go. Make it wider, higher. And it should go behind the camera because we want the camera to be really inside of the particles, right? Okay, so let's just create a bit more particles. Let's try 20. Okay, you can see them, they are there. Let's just change the size to maybe 5. Okay, so we get lots of particles. So currently the particles are cubes, or actually just planes, which are always facing the viewing camera. So what I did here, I was creating lots of roto shapes, and each shape is kind of a shape of a particle. So this is just a sphere kind of thing. This is a hair or something. This is a bent hair. Even more bent, and these are different things of particles which I want to emit from. So these are my particles, and then I just created a switch, and in the switch statement I added a expression, frame minus 1001. 1001 is my starting frame, so if I'm on 1001 I get switch number 0 and so on. So, and then after that I'm writing out a sequence for all my shapes, and you can see the switch is working, and my sequence goes then into the particle slot in the particle emitter. So if this is my sequence and I scrub through it, you can see all the shapes changing, and this is my particle instancer. And if I go now back to the particle emitter, you can see you get all these particles in the air. which is awesome. This is exactly what I want. And you can also change how they are being instanced. So the input order is random. I want to start I can start at the first frame, which doesn't really matter, and I want to advance also randomly. So everything is pretty random. Unfortunately, I don't know a good way to rotate per particle attributes. So what I did in the end, I was just rotating the sprites. As you can see, some of them are rotated like this. Hence, I got a kind of rotated particle. I guess there are better ways to do it, but this is how I figured it, and it works for me. And then if you look through the camera, you can see you get particles everywhere. And if I go in space, you can see them appearing in depth, obviously. So this is the first setup. And then the next one would be to actually see how it fits in the deep data. So to do that, you have the deep data here, and I want to merge the deep with the scanline renderer because the scanline renderer is still in 3D. So all I can do is deep merge, and I'm merging the deep render data and the particle data in one go. And then I can do deep to points, which is just a viewport representation. It takes a while now to compute. Or not. So that's the thing. Sometimes it just behaves very weirdly. It creates these in a streak. I'm not sure why that is. Let's try the different order. Okay. So it's definitely just the input order, which is important. So the main data is coming from the scanline render, and the deep is actually the B stream is the deep stuff, and then the scanline is the A stream. And you can see that the particles are just here in the front, the white dots there. And you can see they are actually represented by those streaks. And now the thing is we need to scale the cube, which is our base emitter, to align better in the space. So this is something which I don't really understand why it is like it is. Like only the particles are in this space, but the box is so huge. So I'm not sure exactly why that's happening. But to represent it better, let's create 50 particles, or like change the emission rate to 50. So more particles are generated in this section. So all I can do now is select the cube and make this a lot bigger. And you can see that they get spread out in the deep space as well, which is what we want. So I want them kind of to go up until there. So let's just make them even bigger. Maybe up to here. It always recomputes everything, so you can see the particles are there now. And now I'm changing the width of the cube as well. Okay, so they're spreading out, which is perfect. They're still very narrow, so let's bring up the cube up. Okay, so that's working. And we almost have it, I would say. We can just go a bit further back and then we should be good. So if I select this guy and move it till here, let's see what we get. Okay, okay. And I think we are good. So the particles go a bit too much behind it. So let's just bring it a tad back. Okay, and let's bring it also more behind the camera. Okay, so now I'm pretty happy with the deep placement of the particles. If I can zoom in there. Okay, where is it? Let's just go through the camera. And you can see particles are there, and they are in front, and they are also behind the mushrooms. It's not as easy to navigate because of the scale of everything. Yeah, so you can see particles are there and also in the deep space. So that is working awesome. And the next step, I just jump back into my camera. You can see the particles are there. And currently they are not rendered perfectly. So let's just go to the final output here, which is this. And you can see the particles are definitely appearing. And let's just try to change the scale of each particle. Let's just try 25. And you can see they get bigger in the render here. And if we go to a different frame, we should see a different seed number. There we go. And I was just jumping through until I found something which was working pretty good. Like this works actually pretty nice. And this is the first setup. So then I was also doing, I was positioning like a background image just behind, so we would get this nice blurring effect. Let's see, where's the final render? Okay, so just that there's something blurry in the background, right? So I was just doing some image searching and I found this nice little forest. I was doing some basic color correction like this, a bit more contrasty, and I was reformatting that, and I was putting this thing on a card, so it's in 3D space as well. So let's just copy this, which is the image data, and create a card. The card image gets this forest, and then we create a scene node for the scanline render, and the scene gets the particles, and the scene gets the card, and then the object or scene gets switched to the scene. Okay, so we just put the scene node in between, and if I go to the scanline render and I go press tab to zoom out, let's see where the card is. It's kind of there, it's very small. You can see the scale of the particle, so we definitely need to scale things up quite a bit. So let's just uniformly scale it by maybe 50, maybe even 250. Okay, and we can see that the particles, they are kind of ending around here. So let's just position the card at that position. And then as you can see, we need to make it a lot bigger. Maybe 500. Oh, we need to go higher. Okay, let's rotate it by a bit. Let's say 20, negative 20. Alrighty, so this is now kind of the plate position. And for now, I will just disable the particles, so we just have a bit faster movements and placements, which we don't really have. Anyways, you can also just use a sphere to project that on. And actually, I think if the image has an alpha channel, we can actually use a cutout. Let's just try that instead. Oh, then we would need to project it, right? Okay, never mind. Let's go with the card. Alright, so going back to the scanline render, let's just use deep to points, and let's look what we get now. So the card is in 3D space, and I want to generate the deep data. Now you can see that the background is also a deep point cloud, which is pretty cool, right? As you can see, this the card is now made of deep points. So the placement, I would say, is pretty good. I guess we just need to scale it up. You can see this is now the plate, so we definitely just need to make it way larger. So I'll just use a uniform scale, making it larger and larger. Kind of this is now the placement. And then you can shift it in X or Y until you're happy with the positioning. Maybe down a bit. Down is this guy. Up, I mean. Until you're happy with your position, right? You can see it's scaled pretty high in X, so Well, anyways, let's just work with that. This is just to show you the steps I did. All right, so now we have particles. We have the plate. And we only missing now is the color information, right? So why do the particles? Okay, the particles are not really currently in front of the camera. So it's a hit and miss thing. So until you find a lucky frame, then you just should stick to that. Okay. It would be nice though if I could find a lucky frame. Okay, there's something. Let's just go up with the size just for the sake of the preview here. Okay, so we got a particle there, there. Okay, so now you see that the color is currently black. And the cool thing about deep stuff is you can project any image onto a deep alpha channel, and we rendered out a deep float, remember? So this is just deep alpha. So what we can do now is we have the render, which is without motion blur, this guy here. And what we do, we use a deep recolor node. And then we take the color, which is our render, and the depth is the deep data. And we connect it up. And then this is a deep representation of our render. So if I go deep to points just to visualize them in the viewport, you can see now instead of black dots, we got now the colored dots. And you can see it's the same thing. We just have them in 3D position now, which is pretty awesome. So this is a deep render. And now what we can do, we can use the deep recolored node instead of the deep merge. So we merge these two together instead, and we look through the results. And this is now the result. We have the particles here's the hair stuff, and then we have the forest and the background. And this is kind of all I did in this node here. You can see it's the same connection, deep combine, deep merge, and then at the bottom I've got the bokeh, which we will be doing now. And just as a reference, this was my reference image in the beginning, so I was really trying to match the lighting, or at least get similar lighting, similar shading, and then also this nice and blurry background. So this is now the result. And what you can do now, you can actually do a pre-comp, which means you can render out this still frame just to get a faster speed up in your PG bokeh. But I'll just show you how the setup is for the PG bokeh quickly. So at first it's a lot of overwhelming, lots of inputs, and you're not so sure what to do here. So the first thing is, if you don't have deep and you don't have the camera, which I highly would discourage from, so I would always recommend to output the deep and the camera data. But if you don't have that, you can actually connect the Z pass, which you get from your render, and you just connect the Z channel here, and then you should be good to go. You can control the front and back multipliers, which is just changing the strength of the effect. But in this session, we have all that, so I'll be using the deep input, which is, I'll just use the, I will not use the raw deep because we don't have the background. The main idea is to blur the particles and the background using the same data. So my deep input actually will be the deep merge data. And my input will be, I think it should be the same, right? So my input is the deep data and my deep input is the same thing, right? So they go both to the same. The only difference is before I use the input, which will not connect here because this is still on deep, I need to do a deep to image, which converts the 3D data to 2D data. And I'm just branching out the deep input and connecting the input to the regular input slot. I hope that makes sense. Okay, so this is the connection, and then I have the camera. And the camera, as I said before, is my Alembic ABC camera, which connects here. And you can actually see the data coming from Maya Arnold is that I've got the f-stop, the focal distance, and these values are exactly the same, which I have set up in here, and the same focal distance should be set up there. As you can see, that's working as well. Okay, so and then if I look through this node now, the PG bokeh, not much is happening, and the thing is on default the real world lens simulation is off, and if this is on, it will actually take the camera data. But before we do, let's just isolate a small area. Let's say I'll just render this section here, enable this, and then it takes a while and it should compute. You can see it's already working. It's magic. You can see the depth of field is happening, and you get the nice bokehs and everything. It's all out of the box, right? And it works super nice. And you've got now several options. You can control the strength of the front and back multiplier, and you can, I think you can also change the focal focus region. But yeah, exactly. So you've got the output types, and if you first want to control where the focal point is, you can actually choose focal distance visualization. Oh, it's a hard word, man. And you can actually see which parts are in focus, and everything which is red is fully in focus. Things which are green is in the foreground defocus, and things which are blue is in the background defocus. And you can see if I change, let's say I want to increase the effect on the front, which is all my front guys here, and I increase the front multiplier, you can see it gets way stronger, which means a lot more blur in the foreground. And the same applies to the background. As you can see, it gets way stronger then. And let's see if this actually works. Yeah, I thought so. This does not work because it's dependent on the real camera data. So this is just a focal distance, and it is kind of fixed. And then we also have the kernel. The kernel is actually the bokeh effect itself. So you can actually control it. And you can also visualize it if you go to filter shape. And let's just disable this guy. Okay, so and this is my kernel shape. Currently it is round. And in lots of movies, you see this octagon shape or something similar. And you can do that if you change the kernel type to be aperture blades. And then you can already see it has 6 corners, and you can change how many blades you want. This shape actually comes from the lens itself, from the shutter. I think it's called the shutter, the exposure aperture. I think that's what it's called. And you can, so most cameras I think have 5 or 6 blades, and the high-end cameras they have more. But it's mostly, I don't know if there is like perfect round ones on the market. I'm not so sure. So what I like to do is mostly use 6 or 8 or 9. In the current final render I had just 6. And you can also change how round it is in here. If you want it to be more round, you can see it's being bloated out. If you want a stronger edgy shape, you can reduce the curvature. So that's kind of that. And then you have cool things like spherical aberration, which means that the center part kind of gets faded out, which you see as well in real life. And you can use chromatic aberration, which is a kind of a lens effect, which changes like the wavelength, how it's being bent from a photo camera. Bloom will exaggerate the blurred elements. It makes a kind of like a glow effect, kind of like that. So defocused image, and before we go, I want to see the visualization. That was better actually. And let's just create a region around here and render that. And you can see now there's the first ping there. And obviously if you want to have more control on the where you want to have the focus, I can show you that as well, but I wanted to the focus to be driven from the render camera, but I'll show you how to set it up. So now you can see you get the nice bokeh in the background there, And let's say we want to focus on the leaves here, right? To do that, let's just change to the visualization quickly. And instead of using a real-world lens, you disable that, and now you have the option to actually define where you want to have the focus. So if you increase the multiplier, then you have the option to, weirdly, you don't have it now anymore, to change the focal plane. I guess it's because I have a camera connected. There we go. So if you don't have a camera connected, you can, let's put the multiplier back to 1. You can say where you want the focus to be. So currently focus is there, and you can change the range to make a wider focus area. And you can see everything here is now in focus. And if I create my little region here and render from there, you should see that the leaves are now in focus. And let's see if we go back here. And currently there is not much blur going on. So if you want to create a stronger blur, you would just increase the front multiplier. And now these guys should get out of focus, which they do a lot though. Yeah, so this is kind of the effect, right? But as I said, I want to use the real world lens data. So let's just connect the camera back up and switch this guy to be real world. It's also longer to render the real world, but it definitely looks a lot better. Let's see what else is changed. This goes back to 1. This goes back to 1. Okay, so this is the setup for PG bokeh. And again, this is the result from that. And I'm pretty much impressed by how good it looks, like all these nice details. Look how nice and crisp this is. And I was saying before that I did not like this thing here, right? And I did some other treatment on that as well. So this is my final image. So this is the image after PG bokeh, and I did a pre-comp, so I rendered it out and brought it back in. So, and this thing was really annoying me. So what I did, it's maybe not the best way to do it, but I created a roto shape like this, just around this area. I created a blur, so I blurred the whole image, and then I used the alpha to drive the mask only, and I added some feather to it, so I get a softer fall off around this. So just to remove the effect a bit on this area. And as you can see now, I've got the volume pass. It's just a black and white defocused pass, and I'm just grading this a bit to make it a bit more contrasty, and I'm just plussing it on top of the render, and this is the effect. Just a subtle glow, which goes in front and in the back. Yeah, and this sums it up. And then I was just rendering out the right nodes, and here we go. Let's just go full frame. Yeah, I'm pretty happy with the result. Like, the shading looks pretty cool, I must say. I'm not so happy, as I said, with the top surface of this guy, but this one is just awesome. I think all this nice subsurface scattering effect, you see the thickness of it. And I also like this mushroom. And you can actually see if you go too close, there's some issues with the deep data. So there's a bit of a cutout, actually. I think it's because I was not really paying attention to where I placed this. But I must say, it still works. I'm still pretty happy. And yeah, if you came this far, I really appreciate your support, and that you actually follow along all the way. Yeah, and if you really like it, I would really appreciate it if you support me on Patreon, and a bit of support is always appreciated. So thanks again, guys, for tuning in. This is now the final part of the 5-part series of the MtoA 510 tutorial regarding Quixel Megascans. And yeah, thanks for tuning in, and I hope to see you in the next tutorial series.